All right, this is just a little intro to Unit 8. In Unit 6, we were adding and subtracting polynomials. In Unit 7, we learned how to multiply polynomials. And now in Unit 8, we're going to be working with factoring polynomials, or breaking polynomials down into the groups of terms that multiplied to create them. And really the first step to working with these is being comfortable finding the greatest common factor. So GCF stands for greatest common factor, and it is the largest number. It is the greatest factor that divides two numbers. So it's the largest number that you can divide two numbers by. So we're going to be able to use this so that we can factor binomials. And eventually we'll be using the difference of squares, but we'll cross that bridge probably in 8.2 or 8.3. So let's just work with the greatest common factor here. And again, this is an intro video. You'll get another video before you start really working on and practicing these. Just follow along and get a good idea of what these are and how these numbers work. Now, if you're really good with your multiplication facts, you can do these in your head and they're going to be pretty quick. If you struggle with your multiplication facts, you can use a calculator. I'm going to give you some strategies to help you figure these out. So here's the deal. The greatest common factor is the largest number that is in common between both of the numbers or all of the numbers given to us or terms. So here we've been given 36 and 24. Think about the factors of 36, and these are the numbers that multiply to make 36. And actually, I'm going to list them like this. So I'm going to put a little table here. And for 36, we have 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. 5 doesn't work. 5 doesn't go in. So these are all of the numbers that multiply to make 36. And then with 24, I'm going to do it right next to it in blue here. 1 times 24, 2 times 12, 3 times 8, 4 times 6, and 5 doesn't work. So I'm going to highlight now in green, or actually use purple, some of the common factors. So 12, 6, 4, 3, and 2. So those are all common factors of 36 and 24. But when we're looking for the greatest common factor, greatest means the largest, and the largest of all of these numbers that are in common is 12 here. So the GCF of 36 and 24 is 12. So if I were to take 12 away from 36 and 24, for 36, it would be 12 times 3, so there would be a 3 left over. And for 24, it's 12 times 2. So the greatest common factor between 36 and 24 is 12. Now, you can always list things out like this, but it is kind of cumbersome. There's kind of a lot of work to it. So I'm going to give you actually, let me zoom back in here and talk about this a little bit. Think about our smallest factor here. So our smaller of the two is 24. Whatever the largest numbers are in 24 is kind of the highest number that we can use for 36 as well. So like I listed 1 and 36 as common factors, but they're not really. 24 tops out at 24. So what we can do here, and I'll show you on example B, is instead of having to list both, we can pick the smallest factor or the smallest given value. So in this one, our smallest given value is 32. And I'm only going to list the factors of 32. So 1 and 32, 2 and 16, we have 3 doesn't work, 4 and 8, 5 doesn't work, 6 doesn't work, 7 doesn't work, and we're back to 8, which we already listed here. So these are our factors. From here, I'm going to start with my largest factor and see if it goes into my other value. So can 54 be divided by 32? Is 32 a factor of 54? And the answer is no. Can 54 be divided by 16? And you could use a calculator to figure this out. You would just write 54 and then hit divided by, and then you could try your different numbers. So you could say 32 and that gets you a decimal, so it doesn't work. You could hit 16 and that gets you a decimal, so it doesn't work. You can press 8. Doesn't work. You get a decimal. Oh, I skipped 9 and 6. Oh, I got you. Because for 32. And then divided by 4 doesn't work. So divided by 2. 2 does work. 2 gives me 27. So that's the only value that works for both of these. So the greatest common factor is 2. She got very confused for no reason. Okay, so check this out. Again, I'm picking the smaller of the two, so 44. And I'm going to list my common factors. 1 times 44, 2 times 22, 3 doesn't work, 4 times 11, and those are all of my factors. Now I'm going to use these factors, and I'm going to divide 121 by each one of these until I find the largest one that works. I start with my biggest and work my way toward my smallest. So I'm going to say 121 divided by 44. And it gives me 2.75, so that doesn't work. 121 divided by 22, and that gives me 5.5, so that doesn't work. It's a decimal. 121 divided by 11. That does work. It gives me 11. So this is my greatest common factor. 11 goes into both 44 and 121. So here my GCF is 11. Okay, and then for 25 and 50. So I'm going to pick my smaller of the two, 25, and I'm going to list out my common factors, or my factor tree. 1, 25, 2 doesn't work, 3 doesn't work, 4 doesn't work, 5 and 5. So these are all the factors. And we are going to start with the largest one, so 25, and we're going to say 50 divided by 25. And that gives us 2. It gives us a whole number. So in this one, 25 is our greatest common factor. 5 goes into both of these as well, but it's not the largest number that goes in. 25 actually is the largest number. So sometimes the number itself is the greatest common factor. Okay, so we're also going to be seeing this with variables. So think about with variables, we have x squared really means x times x, and x to the fifth really means x times x times x times x times x. There are 5 of them. 1, 2, 3, 4, 5. So the greatest common factor would be how many x's can I take? What's the max amount of x's that I can take from both the red and the blue that I have listed there. And the max amount that I can take is 2. I can take 2 away from both of these groups. I can't take any more than 2 because my blue group doesn't have enough to give. My blue group can only give 2. So here, my greatest common factor is x to the second power, because that's the most amount I can take from both. That's the most amount they have in common. So again, for my y's, I'm going to have my red y's, so there's 3 of them multiplying. And my blue y's, there are 7 of them multiplying. And what's the most amount I can take away from both groups? I can take 3 away here, and I can take 3 away here. I can't take any more. If I tried to take 4, this group doesn't have 4 to give. So the greatest common factor that I have here is y to the third. If you've noticed a pattern between a and b, your greatest common factor with variables is usually just your smallest value variable. So let's apply that here on C. So I'm going to look at my smallest x value. So the most amount of x's I can take away from both of these is a 3. So my greatest common factor is going to be x to the third, and then I'm going to look at my y's. And the most amount of y's I can take away from both of these is 4, so y to the fourth. Okay. And then on this one, I'm going to do the same thing. So I'm going to take a look at my a's. The most amount of a's I can take away are 2. So my GCF here is going to be a to the second. Check my b's. I can take b. I have 5 here and I have 3 here. So the most I can take away is 3. B to the third. And then I'm going to check my c's. I have 4 here, but I don't have any c's over here. So because there's no c in this group, remember the word common means that both groups have to have it in common. So if they don't have a c in common, I can't take a c out. So this is the greatest common factor. So now that we've worked with kind of finding the greatest common factor, we're going to actually start factoring them out from groups of numbers, from binomials. And while we're doing this, we're going to rewrite, or we're going to write out what is left over when we take that greatest common factor away. So we're going to focus on numbers first and then variables. So for my numbers, I'm comparing with 2 and 6. So my smallest number is 2. And my factors of 2 are 1 and 2. That's all. And I'm going to say, can 6 be divided by 2 evenly? And the answer is yes. So 2 is a greatest common factor. And then I'm going to look at my variables. I have x to the first and x to the second. Remember, I can only take my smallest x value, so I can take an x to the first out. And then essentially, you can go through and either divide. So 2 divided by 2 is 1. And x squared, if we take 1x away from that, it's going to drop 1 power down to x to the first. And then I'm doing 6 divided by 2, which is 3. And x divided by x, I'm going to drop a power. And so when I take that away, it goes away. So this is what I'm left with. It's essentially reverse distribution. So to check my answer, and you don't always have to check your answer, but I'm going to show you here, I'm going to take my answer, 2x times x plus 3, that's 1x to the first plus 3, and I'm going to multiply it, I'm going to distribute it back in. So 2x times x is 2x squared, and 2x times 3 makes 6x, And if I get the same thing here that I started with here, then my answer is correct. So there's my answer there. All right, so between 6 and 4. Now, if you do these in your head and you look at 6 and 4, you go, oh, the greatest common factor here is 2. And then you just look here and you say, do they both have variables? Yes, they do. So what's the smallest one? That's the most amount I can take away from everybody. And so if I were to take out a 2x squared, if I were to divide it from here, I would be left, 6 divided by 2 is 3, and x to the third, we're taking 2 powers away from that, so it's going to become x to the first. And then I'm going to take negative 4 divided by 2 is negative 2. And we're taking 2 powers away from our x to the second, so there's not going to be any left. So this will be our answer. And to check it, we're going to multiply back in just to see if we get our original. And this will be the last one I check. I won't do the checks on the other ones. So I'm going to say 2x squared times 3x. 2 times 3 is 6. X squared times x is x to the third. And then 2x times negative 2. 2 times negative 2 is negative 4. And we leave that x squared attached. And if we compare, this is the same as this. So we know we did it right. So I'm not going to do either of these check your answer boxes from here. Okay. So with 12, think about your factors of 12. And 6 is going to be our greatest common factor. So if you were able to think of it, great. If not, you can always list your factors of 12. You always pick your smaller number, so either 12 or 18. 12 smaller. So 1 times 12, 2 times 6, 3 times 4. Those are our factors. And then we start with our biggest one, and we compare to see if it fits into our other numbers. So 18 divided by 12 would get you a decimal, so that's no good. 6, 18 divided by 6 is 3. So we could take a 6 out. And then I'm going to look at my y's. They both have y's, and I can only use the smallest value y. So this is going to be 6y to the first. And then we write what's left over. So we can divide. 18 divided by 6 is going to give us 3. And y to the fourth is dropping by y to the first. It's dropping 1 power, so it becomes y to the third. And then negative 12 divided by 6 is negative 2. And y divided by y is goes away. So this is our answer. These typically are done kind of more mental math. So if you feel like I'm over-explaining and you kind of get it, then just go with that. But I'm trying to give as many tips and tricks and tools and all that kind of stuff to help everyone, no matter where you're at with this. So I'm going to pick my smaller of the two numbers. So I'm going to take 14, and I'm going to list the factors of 14. So 1 times 14 and 2 times 7. Once I've listed them, I'm going to compare them to see how they fit inside of my other numbers. So 49 divided by 14. So I'm going to look for 49 divided by 14. You could do that in your calculator. And it's going to give you 3.5. So if I get a decimal, it doesn't work. So now I'm going to check 7. I'm just going to hit backs, and then 49 divided by 7 is 7, so that works. So my greatest common factor is 7. And then I'm looking, do these both have a common x term to pull? And the answer is no. So there's no common x to pull from these, so the only thing in common is a 7. And when I divide that out, 14 divided by 7 is 2. And x to the third isn't changing because I'm not dividing out an x. And then 49 divided by 7 is 7. And this would be factored down. That's our greatest common factor. So we'll continue working with these and practicing them. But I just wanted to give you kind of a little bit of a practice video where you're seeing it, and hopefully it makes a little bit of sense. And we're just going to keep practicing this until we get better and better at it.